Hello everyone. So in this video we're going to talk about section 8.3 which uses inverse trig functions continued. Okay, so in this section we're going to try to answer different problems using the same sort of approaches that we have been in the last two sections. And so these are just different problems where you may see inverse trig functions encountered. Some of these problems are not going to involve inverse trig functions the way that we solve them, but they're there nonetheless. Okay, so let's see some examples. So again, in these slides, I've solved the equations out, okay, and then I'm going to talk through, so all the work is there. I'm just going to talk through what I'm doing. So this first question says, determine whether pi over 4 and pi over 6 are solutions to the equation 2 sine of theta minus 1 equals 0. So this is not going to involve any inverse trig functions at all, but it's still something of interest and it's included in this section. So first, let's check the sign of pi over 4, whether that is a solution. So sine of pi over 4, pi over 4 is 45 degrees, so it's a special right triangle of 1, 1, square root of 2. And so the sine of pi over 4 is square root of 2 over 2. So I've indicated that on the left. And then I asked the question, is 2 times the square root of 2 divided by 2 minus 1 equal to 0? And it is emphatically not. Square root of 2 minus 1 is not equal to 0. And so pi over 4 is not a solution to the equation. Okay, so what about pi over 6? Well, we do the same thing, only pi over 6, which is 30 degrees, is not the 1, 1, square root 2 special triangle. It's the 1, square root 3, 2 special triangle. Okay, so pi over 6 forms that special triangle up in the right, and the sine of pi over 6 is 1/2. And so the question is 2 times 1/2 minus 1 equals 0? And that emphatically is yes. And so pi over 6 is a solution. Pi over 4 is not a solution to that equation. Okay. The big addition that we're working on in this section is that we're working with equations now. Okay, so now next there will be a number of questions that you'll be asked of this form. Solve the equation cosine of theta equals 1/2, and then give a general formula for all of the solutions. So the first one is fairly easy. So I've got cosine equaling to 1, cosine of some angle equals 1/2. Again, when you see 1/2 as a solution to the trig function of some angle, you should think the 30, 60, 90 special right triangle, because one side is 1 and then the hypotenuse is 2. So after you draw that right triangle out, you find the cosine of pi over 3 is actually equal to 1/2. Okay, so cosine, so pi over 3 is one solution. Great, so that's our first solution, but I want all the solutions. So remember that cosine repeats itself every so often. Okay, it's period, so it repeats every whatever. And so that means that every whatever length of space that cosine repeats itself in, every so often it's going to equal 1/2 again. So there's not just one answer, there may be a bunch of answers. And so the question is, what is the period of cosine? It is 2 pi. And so I then, with that information, can give the general formula for all of the solutions. And so the general formula is that original solution that we found, pi over 3 plus 2 pi k. And so I put the 2 pi because it's the period times some integer k, so some whole number k, where k is any number from negative infinity to infinity, but it has to be a whole number. Okay, it can't be a decimal. -2, -1, 0, 1, 2, all the way up, and then all the way down to negative infinity. Okay, so hopefully that wasn't too hard. There'll be a number of different problems like that on the homework quiz, and will definitely make its way onto the final exam. Okay, so now I deal with a similar sort of problem, but I don't want a general solution for all of them. I just want the solutions between 0 and 2 pi. The only thing that's tricky about this kind of question is now it's not the sine of theta, it's the sine of 2 theta. Okay, so how do I sort of solve this problem? Well, I'm going to set 2 theta equal to alpha. I'm doing that because I know the sine of an angle equaling a half. That's a fairly easy problem for me to solve. But the sine of 2 times an angle equals 1/2. That's a bit harder. So I set alpha equal to 2 theta. And so now I'm trying to find the sine of alpha equals a half. That's fairly easy for me to do. It's pi over 6, okay, using the same logic that I talked about in the last problem. So I know that alpha is equal to pi over 6. And so then what is theta? Because alpha equals 2 theta. So if alpha is pi over 6, then theta is pi over 12. Okay, so great. That's one solution. So I know one solution, but it is possible that there are multiple solutions to this question between 0 and 2 pi. So pi over 12 is 1. Then I've got to think about what's the period of sine. Well, the period of sine is 2 pi, but we aren't looking for just the period of sine or sine of theta. We're looking for the period of sine of 2 theta. And so what does that 2 do inside? Well, if you think about, we talked about the amplitude and the period of a function and how numbers inside the sine change that. The 2 inside there speeds up the period by a factor of 2. And so it speeds it up, it goes twice as fast. So the period of 2 theta is equal to pi. So I'm going to use the same sort of logic as I did in the last one to get all the general ones, but I'm only going to keep the ones that are in between 0 and 2 pi. So I have pi over 12, and then I add pi to pi over 12, and I get 13 pi over 12. Hopefully that made sense. I added pi to pi over 12, and I get 13 pi over 12. So that's my second answer. And then if I add pi again to 13 pi over 12, I get 25 pi over 12, which is slightly larger than 2 pi, and so that is not a solution. So it turns out that the only 2 solutions to this problem are pi over 12 and 13 pi over 12. Okay, so hopefully that made sense. I'll move on to a similar problem. Now, this problem is similar, but yet slightly different, because I want you to use a calculator to solve the equation. Right? So I have tangent of theta is equal to -2, and I want you to find all solutions, all values of theta that make that equation true between 0 and 2 pi. And so there is no special triangle that's going to get us this value exactly, so we need to use the calculator. Remember that you have on your calculator an inverse tangent button. Okay, and so if I use inverse tangent to switch the equation tangent of theta equals -2 to theta equals inverse tangent of -2, okay, I can then substitute that into my calculator, and the inverse tangent of -2 you'll find is equal to -1.107. Now that is a solution to the equation that we have, but unfortunately it's not in between the intervals 0 to 2 pi. So that's not going to be a solution to our problem, because of course it's a negative number. So what we need to do is figure out the period and then keep on adding numbers or subtracting numbers until we get values that are in between 0 and 2 pi. So it turns out that the period of the tangent function is pi, not 2 pi, but just 1 pi. Okay? And so if I add pi to negative 1.107, I get 2.035. I've always rounded these to 3 decimal places. Of course, there are many more. I just will always round to 3 here. And so I get 2.035. That is, in fact, in between 0 and 2 pi. Now, you may be thinking, well, these are decimals, and I'm used to pi's being in there. So how do I check if a decimal is in between 0 or 2 pi? Well, you just have to find out what 2 pi equals as a decimal. And so I've done that up in the right-hand corner there. 2 pi is equal to 6.283. Okay, so 2.035 is in between a 0 and 6.283. Great. So now let's take that value and add pi to it, because of course tangent is going to repeat every pi. And so when I do that, I get 5.177, which is in between 0 and 2 pi, so it's my second solution. And then if I try again to add pi to 5.177, I'd get 8 point something, which is definitely bigger than 2 pi, and so wouldn't be a solution. So overall, I get 2 solutions, 2.035 and 5.177. Okay, now let's move on to yet a different equation. Okay, that involves sines and inverses, possibly. I want to solve the equation 2 times the sine squared of theta minus 3 sine of theta plus 1 equals 0, and I want the solutions between 0 and 2 pi. Okay, so I have a quadratic form here. I have something squared minus or plus something, and then plus or minus some number equals 0. That's called a quadratic form. Okay, and so I need to try to simplify and solve in the way that you probably know how to try to solve these problems. But it looks awfully weird with signs there, and so I want to change to x. And so I'm going to set x equal to sine of theta. All right, so I do that, and I rewrite the equation above in terms of x instead of sine, and that becomes much more workable probably for you. So I want to try to solve the equation 2x squared minus 3x plus 1 is equal to 0. Okay, and so I factor that out, or reverse FOIL, or whatever you want to call it, and I get, after some work, that x either equals a half or 1. Okay, both solutions will get me that the equation, the left-hand side of the equation, will equal the right-hand side. Okay, so either 1/2 or 1. So I have to take those values of x and then go back to the relationship between sine. So now I need to see what thetas get me that sine of theta equals either a half or 1. 1/2 is the easiest because we've been working with it a lot. The sine the sine of what equals a half? The answer to that, using the special right triangle, is pi over 6. Okay, so the sine of pi over 6 is equal to a half. So that's one solution, and sine repeats every 2 pi, so there isn't going to be a second solution from this part of the equation, sine of theta equals a half. Okay, so the next time where the sine of theta will equal 1/2 is going to be at greater than 2 pi. All right, so pi over 6 is one solution. Now I need to look at what if sine of theta equals 1. This is a little trickier because 1, 0, and -1 often happen at quadrantal angles for sine, cosine, tangent, so on and so forth. So sine of theta equaling 1 happens at a quadrantal angle. And so if you just look at the plot of sine of theta, you'll see that it equals 1 at pi over 2, or 90 degrees. Again, sine repeats every 2 pi, and so the next solution, where sine equals 1, is going to be outside of the range 0 to 2 pi, and so I get my two solutions, pi over 6 and pi over 2. Okay, so I know that was a lot of work, more than the other two questions. Hopefully that went okay. If it didn't, make sure to contact me after we can discuss. All right. So now the last one, last slide, I believe. I have 3. So now this gets even more involved because I have cosines and sines all together. And so this is sort of the culmination of what we've been doing in the slides before this one. I have 3 times cosine of theta plus 3 is equal to 2 sine squared of theta. Okay, so I have sines and cosines in together. Not a great idea, so I have to think about what identities do I know that are going to help me with this problem. And the identity that is going to help me with the problem is that sine squared plus cosine squared equals 1. Now, I can rewrite that as I did over on the left side at the top of my work. I can rewrite that sine squared of theta is equal to 1 minus the cosine squared of theta. Okay, so that's just a rewriting of the fundamental identity. And I did that because I want only sines or only cosines. And it was probably easier for me to get rid of sine squared than it would have been to get rid of just cosine. So I replace sine squared. I replace sine squared with 1 minus cosine squared. So then I do some algebra, and then I get down after that to the equation 2 cosine squared of theta plus 3 cosine of theta equals 1, plus 1 equals 0. And again, I need to solve for theta. So I use the same trick I did in the last problem. I let x equal cosine of theta, and I work down to find that x was going to equal either -1/2 or -1. So similar things as the last problem. Now comes the part that's a bit more challenging than in the last problem. Okay, and that is, where is the cosine of theta equal to -1/2? I know that cosine is positive in the first and the fourth quadrants, and so this has to happen in either the third or the second quadrant. Okay, and so it turns out that it happens in the second quadrant. So cosine of theta equaling -1/2 happens at, if I draw my triangle, 2 pi over 3. Okay, happens if I draw my special right triangle, where adjacent is going to be -1. I'm sorry, and opposite is going to be the square root of 3. And then hypotenuse will be 2. That angle is pi over 3. That, of course, is the reference angle for the real, quote-unquote, real angle. And the real angle is 2 pi over 3. Okay? So, great. That's 1. Does that happen anywhere else? Do I get that the cosine of theta is equal to 1/2 anywhere else? And the answer is no. Okay? So the answer is yes. I made a mistake. Okay? If you flip that triangle down, you're going to get another answer. And that answer is going to be pi plus pi over 3, which will be 4 pi over 3. Okay, so then the other answer that I don't have included here is 4 pi over 3. Okay? All right. Now, those are the two answers that should be there for cosine of theta equals negative a half. What about cosine of theta equaling negative 1? That is another quadrantal angle, okay? And it turns out that that angle is pi. Okay, so pi. And so the final answer, one of which I missed, is 2 pi over 3, 4 pi over 3, and pi. Okay? Now, on that note, that means I made a mistake back here. When is the sine of theta equal to 1/2? Certainly that's equal to pi over 6. But it turns out that sine is also positive in the second quadrant. Okay? Sine is positive in the second quadrant. And so where else is sine going to equal 1/2? It's going to equal 1/2 at 5 pi over 6 as well. So the three answers here are pi over 6, 5 pi over 6, and pi over 2. I will fix those mistakes in the completed form that I give you. Okay? So thanks for sticking with me. Sorry I made a mistake, but that happens every once in a while. I will see you next time.